is the second part of the first unit. Here in this one, we are discussing about database is relational data model. What is actually the contents which are available in the relational model are basic terminology, structure of the relational databases, database schema, keys, schema diagrams, relational query languages, the relational algebra, etc. Now comes to the fundamental or relational data model. Here is relational data model was proposed by the EF code. Relational model represents how the data is stored in the relational database. It represents how the data is organized, stored in the databases. A relational database stores data in the form of relations. Those are called as the set of tables. The form of set of tables. Set of tables. Now coming to the next slide in this one, the basic terminology for this one. Here it is the student relation which contains roll number, name, address and phone and age. Next, student contains. Now these are the attributes which are available in the student table: roll number, name, address, phone and age. Now what is actually the basic terminology here is attribute. Attributes are the properties that define a relation. Now here the roll number is one attribute and name is the another attribute. Now coming to the relational schema. A relation schema represents the name of the relation with its attributes. Now for example, student is the schema or relation which contains the attributes roll number, name, address, phone, age, etc. Here comes to the third one, tuple, row or record. Each row in a relation is known as tuple. The student relation contains 4 tuples, one of which is shown as. Now this is about the 101. First row is there and the sum of the they are specified in this one. Now what is actually the relation instance? What is actually an instance means the set of tuples of a relation at a particular point. At a particular point, what are the things which are available? What are the values which are available in a relation? Called as relation instance. Of type are called in instance. The above table shows the relation of student at a particular time. It can change whenever there is an insertion, deletion or updation in the database. What is actually the degree? The number of attributes in the relation is known as the relation. For example, if you are having 4 attributes, the degree of the relation is 4. If the relation is having 3 attributes, the degree of the relation is 3. For example, the degree of the student is 5, which contains 5 attributes. Now next comes to the cardinality. The number of tuples in a relation is known as cardinality. The cardinality of a student relation is 4. Now the student relation contains only 4 records. The cardinality is 4. What is actually the null value? The value which is not known or unavailable is called a null value. It is represented by a blank space. Example, phone of a student having roll number 104 is null. Now coming to the arity, the number of attributes in a relation is also called as in a relation. Now arity, it is called as cardinality, number of rows. Now comes to the arity means number of attributes. What are the attributes which are available? How many number of attributes are there, which is called as arity. The student arity is 5. Domain of attribute. Possible values of an attribute is called as the domain. For example, if you are taking a bank name, some branches are there. How many branches are there in the particular district is called as the branch name of the district domain. Now coming to the, this is about the domain of the phone in student relation is integer because it accepts only numbers. Okay, I will upload the next one. Now coming to the next topic, relational schema and instances. Here, what is actually the relational schema? Now, here R equal to some set of attributes A1 to AN is a relational schema. Here comes to the A1, A2, A2 are the attributes. For example, instructor is equal to ID, comma, name, comma, department name, comma, salary. Now, this is about the instructor schema. A relation instance R defined over relation schema R is denoted by R of this one. Okay, relation schema and instance already you started this one. Now we are in this one. An element T of relation R is called a tuple and is represented by row in a table. Example for the instructor relation is this is instructor relation ID, name, department name, and salary. Now coming to the attributes, the set of allowed values for each attribute is called as the domain of an attribute. Attribute values are represented to be atomic, that is individual. Multi-valued attributes are not atomic. For example, if you are having more than one value, it is not atomic. Composite attribute values are not atomic. So now the combination of two or more values is also not atomic. Now this is about the null value. The special value is null value, which means the value is not available and not applicable. Now coming to the relations are unordered. Now you can specify any order. the relations of which is available in the this one, you can also specify in any order. Now coming to the database schema, already we discussed about the schema. A database consists of multiple relations. Information about an enterprise is broken up into parts, with each relation storing one part of the information. Now it contains number of relations, more than one relation, and it is also joined by using some set of joins also. For example, university database contains some set of instructors, some departments are there, and many number of students are there. These three are linked. Now, database schema is the logical structure of the database. Database instance is a snapshot of the data in the database at a given instant in time. For example, schema, instructor. This is about the structure, instructor ID, name, department name, salary, etc. Comes to the instance. At a particular moment of time, what is the information available in the instance is called as an instance. Now comes to the keys. These are very, very important concept. Let K subset are equal to relation. K is a super key of R. If values for K are sufficient to identify a unique tuple of each relation or of R. For example, ID and ID comma name are both are super keys of the instructor. Super key is a candidate key if K is minimal. K is minimal. Generally, super key is candidate key. Minimal set of super key are the candidate keys. One of the candidate keys is selected to be the primary key. A foreign key constraint, value in one relation must appear in another relation by using referencing relation or a referenced relation. For example, department name in instructor is a foreign key from instructor referencing department. For example, department name in department is a primary key from department referenced instructor. Now, identify a row uniquely in a relation. Super key. It is a key which identifies a row uniquely in a relation. Key plus additional attributes is called as a super key. Candidate key. Minimal super key is called candidate key. Primary key. If a relation has only one candidate key, then the candidate key itself is a primary key. If a relation has more than one candidate keys, then choose any one candidate key as a primary key. Now this is our example: student ID, name, address, age, etc. Key, student ID, super key, student ID comma name, student ID name, address, student ID name, address, age. These are the super keys. Now note, name comma address is not a super key. Candidate key, student ID. Primary key is also student ID. Now this is about the some set of keys: key, super key, candidate key, primary key, etc. Now this is about the schema diagram of the university database. Here some set of sections are there, some set of faculty details are there, instructors are, advisors are there. Those are linked based on the some set of relations are there. Those are linked and formed the database. Next topic in this one is, I'll upload this one. Okay, coming to the next topic. Relational query languages. This is a very important one. Language in which user requests information from the database. Categories of languages are there. Some set of categories of some set of languages, procedural as well as non-procedural or declarative. Pure languages, relational algebra, tuple relational calculus, and domain relational calculus. A relational algebra is a procedural language. It consists of set of operations that take one or two relations as inputs and produce a new relation as a result. A relational algebra is a more powerful tool which is the basic for creating the structured query language, etc. Some set of operations are there, some set of operators we are using for selecting something, etc. Or many number of things we are using. Now coming to this one, these are the very important thing. Relational algebra. The relational algebra is a procedural language. It consists of a set of operations that take one or two relations as inputs and produce a new relation as their result. These are the fundamental operations which are available in the relational algebra: select operation, project, and then union, set difference, Cartesian product, and then row, rename. And coming to the selection operation, here by using the selection operation, we can select some set of rows from the relation. The select operation select tuples that satisfy a given predicate denoted by lowercase Greek letter sigma. Now this is the notation we are using. Here this is a predicate here. This is the symbol we are using. This is the relation R. P is called as a selection predicate. For example, select those tuples of the instructor relation where the instructor is in the physics department. Now query department name is equal to physics of instructor, some result are displaying. Now some set of ID, name, department name, salary, etc. Now selection operation, it allows comparison operators in predicate. For creating condition or predicate, it allows these 6 types of relational operations: is equal to, not equal to, greater than or equal to, less than or equal to, etc. It also allows some set of connectives also, logical operators, and, or, and not. Find the instructors in physics with a salary greater than some $90,000 or 90,000 rupees. Now this is about the thing. Department name, physics, salary greater than 90,000 from the instructor. Now comes to the projection operation. This is a vertical level thing. By using this projection operation, we can select how many number of attributes are there to display for a output relation. The projection operation is a unary operation. It is denoted by uppercase Greek letter pi. Now it uses the notation like the pi, a1, a2, a3, and so on up to relation. Now these are the attributes and R is the relation name. Now example, display the ID, name, and the salary attributes of the instructor. Now this is about the query. Pi ID name, some subscript is the name comma salary from the instructor. Now the result will display the ID, name, and salary of the from the instructor. Now coming to the comparison of selection and projection operations. Here the selection operation is used to composition of this one, composition, not compare, composition of selection and projection operations. Here we can mix or compose the projection and selection, and then we will able to get the selected number of attributes and selected number of rows based on some predicate. Consider you can find the names of all the instructors in the physics department. Now this is about the pi of name. Here you can select, you can project, here you can select some physics department instructors in the physics department. From this one, we will easily project the name also. Instead of giving the name of the relation as the argument of the projection operation, we can give an expression that evaluates the relation. Now this is about the output for this one. Now comes to the union operation. The union operation allows us to combine two relations. Now this is about the notation we are using. This is valid. Now here, if you want to perform the union operation, R and S should have the same arity. What is actually the arity here is already we discussed about the arity. The total number of attributes which are available in the relation are same. The attribute domains must be compatible. These are the two must be compatible from the tables. This is about the output from this relation. Now comes to the set difference. Now this is a notation we are using, defined as R minus S something is there such that T belongs to R and T not belongs to S. Such difference must be taken between compatible relations. R and S must have the same arity. Attribute domains of R and S must be compatible. Now this is about the R and S. The output for this one is R minus S. Here is just which is available in this one, alpha and 1, which is not available in this one. But this is available here, also available here. This is eliminated, and it is available in this one only, but it is available here. It is also eliminated. Now the output is alpha 1 and beta 1. This is our output of the minus operation. Now comes to the Cartesian product. It is very useful. It is also very useful to, which is used in the SQL queries also. Cartesian product. The cross product operation is denoted by X. Now this it allows us to combine information from any two relations. We write the cross product of relations R and S as just R into S. Now these are the Cartesian product. Here 2 columns are there, 3 columns, and the output will produce the 2 plus 3, 5 columns. But here 2 rows are there and 4 rows are here. 2 into 4, 8. 8 rows are there in the output relation. It's a rename operation. We can also perform the another name by providing the new name to existing name. Using the rename operation, we can give new names to old names of the relation. The rename operator denoted by lowercase Greek letter rho. Now this is about the example. We can specify this is the existing relation. We are specifying the X as the new name. Now some of the additional operations we are discussing here: set intersection, natural join, division, and assignment, etc. Set intersection, already we discussed about the union. Now here also this is the intersection operation. We are all know about the what are some similarity it should be maintained. Both relations or both rows which are available in first relation as well as second relation. In this one, alpha 2 is available in two relations. That is the output of the set intersection operation. Now comes to the natural join. Now this is about the initially the Cartesian product is performed. From that Cartesian product, it is equalized based on the one attribute. Relations, let's consider the pair of the attributes something. Now this is about the output. Notation is this one here. By using this one, we can specify the natural join operation. Based on one column, we are performing the natural join operation. Now here is R and S are the relations. Result schema is the this one. Here S is defined as, this is about the from this one. Here these are the things. These are the completely based on one relation. R and S, the output will produce like this. Here these are the very important. Here we are joining this one. This is basically Cartesian product, and then we are performing the join operation based on the same attributes. Now division operation, it is also very useful to reduce the columns or something. These are the R and this is this one. Now here we can remove BB and we can also produce the A. This is about the R and S. Now we can produce finally BB are cancelled. We can produce only A, which are similar in the B as well as BN. Of next one, the assignment operator is denoted by an arrow towards the left side and works like assignment in any programming language. Example: find all instructors in physics and music department. Here just we are taking, this is about the physics, this is about the music. We are performing the union operation. It will produce the instructors which are available in the physics as well as music departments. Now here some equivalent queries also available. There is more than one way to write a query in relational algebra. Now you can use, many users or many programmers use their own views or their unique ways to represent the programming or to represent the queries. Here, find information about courses taught by instructor in physics department with salary greater than some 90,000 or something. Now comes to this one, this query 1 here. This is about the thing query 2. This is about the, these are the different ways we are using. Here we are using AND operation, but here using two different types of selection operations. These are the two equivalent queries. These two are also identical. Now, thank you. This is about the part 2 of unit 1.